I'm Dr. Karl, coming to you from the lands of the Gadigal people of the Eora Nation. I acknowledge Aboriginal and Torres Strait Islander peoples as the first Australians and traditional custodians of the lands where we live, learn and work. G'day, Dr. Karl, Shadows of Science, University of Sydney, talking with Professor Roland Fletcher. Have I got that pronunciation correct?
Yes.
You're a professor of theoretical and world archaeology.
Indeed.
Never heard of that before. You're kind of blowing my mind with regard to no mechanised technology in interstellar space, no galactic empires or civilizations, no Star Trek, no Star Wars, no Dune, no Foundation, no starships, no Dyson spheres. We'll have to go to something else. Basing this on several decades of work in archaeology, how cities grow,
and how settlements
grow from tiny villages and getting bigger and bigger, and how much energy they need and how they send information across to each other. Part of me wants to believe that we'll have starships and metal-based technology, but you're saying that looking at what we've seen over a long period of time, going back over several thousand years, and you blew my mind with the idea that Rome had one of the highest population densities ever in the history of humanity.
Very high, yes.
Really?
Yeah, multi-storey buildings.
What, they had multi-storey buildings in Rome?
4 to 5 storey buildings, apartment buildings.
And so that was a walled city, was it?
It became a walled city. It wasn't originally.
And how big would that have enclosed?
About 18 to 20 square K, depending upon how you calculate the area.
But then you mentioned another city in China, which I'd never heard of, which apparently was the largest walled city in history. What was the name of that?
That's Chang'an. That's the Tang Dynasty capital in China. China generally has the biggest pre-industrial cities on the planet in terms of compact cities. Not low density, but high density compact cities. And it's about 90 square K in total. Just to go very, very briefly, I'm also very grieved that there won't be starships.
Well, it breaks my heart.
It's one of the things that's bothered me for quite some time. And I have refrained from pursuing this because the implications trouble me. And I realised that the problem existed in the 80s. I mentioned it very carefully in a note in the book I published in 1995.
And what was that book called?
That's The Limits of Settlement Growth.
Which is what you've been looking at over several decades, concentrating on just this single aspect.
What I did was I went to work instead on low-density systems, which is why most of my work is known for places like Greater Angkor in Cambodia. So I went to look at low-density systems rather than the high-density ones, which I'd been looking at before. What troubled me was that the analytic tool I'm using are called the interaction communication model.
What? Interaction?
Communication model.
Okay,
and that's extremely simple. It's a bivariate graph.
What does that mean?
Well, there's population on the horizontal axis and density on the vertical axis.
Okay, so population versus density, gotcha, yep.
And on that diagram, the diagonals are areas of settlements. The key is this: communication is a function of distance. The energy you have will allow you to shunt information over some distance. So if I'm speaking to you by word of mouth, I can manage probably to shout at you across a lecture theatre. But it's much easier to talk to people using the microphone, which is pumping energy into doing that. If I'm going to shunt information across a whole city, modern city, I need industrial technology to do that at the moment. With density, if you want to experience density in its stressful form, get on an underground train in the rush hour. You shut down. Basically, you don't have chatty conversations with people who are jammed up against you because it's stressful. And there is a limit, an upper limit, which you can quantify very easily just by taking cases from all over the world, beyond which settlements don't go.
So settlements go to a certain
density,
no, not surface area, but density,
and they can't go any higher. So
and this is what you noticed.
That's right. Rome is right up at the top there. Alexandria is pretty high up. But hunter-gatherers who live in very small camps, like the Kung Bushmen in the Kalahari, there are only 10 or 15 people in a group. They have incredibly high densities.
in that little
in their
group.
little camp.
And that camp might be, say, 10 metres across or 20?
Something like that.
Ballpark figure?
That's right. So they can operate at very high densities, but they aggregate and depart all the time.
Oh, so they don't have fixed buildings.
No, they can come and go, and they change the groups that they're in. So the key issue is that there are two factors which limit the workings of a settlement. One is density, and the other is area. And the key point about those two limits, and this is what I realised in the 80s, is that they're universal.
So you were looking at many societies across the world, and going back how many thousand years?
The metrical data for settlement populations goes back to about 300 to 600 BC.
So that's 2,500 years almost.
Yes, roughly. Yeah.
Okay.
Now, what is worrying about these two limits is that they are limits everywhere in the universe.
Hang on, wait a second. You're jumping from planet Earth to the universe.
Yes. These are boundary limits. The boundary limit on density is the functionality of brains. If you are a social animal, you're autonomous individuals. There's only a finite amount of interaction you can put up with other beings like you. And that would be universal. Anywhere in the universe, any social animal that's terrestrial would have that density
When
limit.
you say terrestrial, living on land rather than in the ocean?
Living on land, yes.
Would it be different if they lived in the ocean?
The arguments about marine are very interesting.
Okay, forget marine. Okay.
So let's leave that aside.
Okay,
for
so
the
we'll
moment.
stick to
We may come back to that.
So you're trying to make a jump from Earth to anywhere in the universe.
It isn't so much that I'm trying to make a jump. I can't avoid it. The other one is communication distance. That will apply everywhere in the universe. The more energy you can shunt into communicating, the greater the distance you'll be able to communicate across. So those two limits are universal and absolute, which would mean that any intelligent terrestrial social life form, I'm being very particular about that, anywhere in the universe has those limiting conditions. And then the really serious issue is what you see with us.
So the two limiting conditions are the density
and the area of the settlement.
The density and the area.
Yeah.
And where does communications...
In the longer term, you have to have more energy if you're going to shunt information over larger distances.
But also you need energy to run the society.
Yes, that's right. But that's a feeding supply issue. The limits I'm talking about are behavioural limits.
Oh my God, so you're diving into psychology of the social creatures that live in these settlements.
It's built into the behaviour of the animal, and the implication is it's built into the behaviour of any terrestrial social animal. The added catch is this: as you're aware from what we've got on us, what's around us, we are a material animal. We use material.
So we've got short-term materials like fabric, and medium like wood, and long-term like metals and stone.
Concrete and so on.
Yeah.
And we started doing that about 3 to 4 million years ago.
So you're talking stone tools and wooden tools as well back then?
And bone. And the great thing about hominins, that's us, is that we're messy. We make dirty campsites. Archaeologists couldn't do their job if human beings weren't messy.
I had never thought of that, but thank you, yeah.
Archaeologists study other people's garbage, basically.
Right, the stuff that they leave behind, that's left behind for...
So the critical issue is that once you start using material in your existence, you can't escape it. It becomes an inextricable part of your behaviour. We can't delete the material in this form from our behaviour. The effect of that is that material will manage interaction. The best example is your teenage child's bedroom door. They can shut the door, they can do what they want to do behind the door, and you don't know about it, and you can't hear it, or whatever it is. With communication, if you introduce material into communication, you can produce systems that make more energy, and you can produce devices which shunt information, If you're using material, for instance, you can write stuff and you can send a piece of paper or a clay tablet to somebody. So the critical problem is that if you're an intelligent social life form and you build material into your behavior, this process of accelerating increase in size of settlement will occur, and you will be able to manage larger and larger numbers of people at the same maximum density. And those consequences are inescapable.
Can you give us some examples in cities that the audience would know over a period of time?
You go from, say, a village like Chattelhewick, about 15 hectares.
What is this village that I as an archaeologist have not heard of?
This is an early agricultural village in
where is
Anatolia.
Is that near Turkey?
Yeah, it's in Turkey.
You can tell how bad my knowledge is. So what's the village called?
It's called Chattelhewick.
And how far back does that go?
That goes back 7,000, 8,000.
Wow. Okay. Can you tell us about that village?
And that's about 15 hectares in extent. All the buildings are packed together, so it's quite dense. You walk across the roof from building to building.
Really?
Mm-hmm. Yeah, I've actually lived in a village in Ghana that worked in the same way.
You walk from one place to another,
and then you go down into the houses
via ladders or something.
Yeah.
And is it a walled village?
No. It just has a solid outside boundary because of the walls.
How do they get their food and their water, and how do they get rid of their waste?
Well, you have doors in from the outside, and then you carry stuff in and out.
And so they must have fields outside that they
that's right.
till?
Yeah, and they're hunting as well. So they're living relatively densely, but in a very small settlement. When you get to, say, 3000 BC, you start getting in Mesopotamia an urban settlement like Uruk begins to develop.
So Mesopotamia literally means between the rivers, so
that's down on the Euphrates and the Tigris.
Okay, and that includes Baghdad.
That's right.
Okay,
but they're much later. The early cities are about 3000 BC in the southern portion of the Mesopotamian valley. And Uruk gets to probably 1 square K late in the 4th millennium BC, and it's 5 square K by 2900.
So it survived for a couple of thousand years?
Oh, and then it survived beyond that. But that's quite densely packed. The buildings are quite close together, but it has thousands of people in it.
Thousands?
Yes.
But once again, that means that there must be a huge periphery of agricultural land and hunting land where they can get their food that
they're taking more and more control. This is where you begin to get early empires and so on, the small empires. The next jump doesn't occur until the 19th century.
What? We go a couple of thousand years?
Oh, yes. Yeah.
Now, do we bypass the mid-1700s and the coal and industrial revolution?
No, that's the Industrial Revolution. You're getting all those antecedents which will make the big cities centuries before the industrial urban transition occurs in the 19th century.
So this is the advantage you have as a archaeologist working for many years, that you get the big picture view, which I don't have.
That's right. What you see in Europe is that you get systems like clocks and printing 400 to 500 years before the industrial transformation for which those are critical communication tools.
You needed those.
They have to be in place.
They have to be already in place.
That's right.
So that was a printing press and the clock. Why the clock?
The clock came into being in cathedrals to manage religious time.
Oh, to make sure everybody turned up at the right time.
And that ceremonies were on schedule. Nothing to do with the value of time or managing people's work. And the printing press came into being to create vernacular Bibles. The Bible was conventionally in Latin, and one of the big revolutions was to break out of that and print Bibles in vernacular languages, German, English.
The local language?
That's right.
Assuming that the locals could read, which not everybody could back then.
Some of them could, and increasingly there's a mercantile class that can.
Oh, the merchants who
So there's a broadening population in the cities which can read. Essentially, the printing press is part of a revolution. It's part of an intellectual revolution. But it's, again, nothing to do with printing, account sheets, nor newspapers originally.
For the vernacularisation of the Bible?
It was mainly for vernacularisation.
Is that a word that we just invented?
No, it'll do. It'll do.
But that led to this big
jump. So what happens at the beginning of the 19th century is that London...
19th century, so that's the 1800s.
That's right. Yep. Jumps beyond 100 square K and expands almost astronomically. It's expanding at several thousand square kilometres per century. You know, it's a really serious boom. So we live in Sydney, which now covers about 5,000 square K, and that's a consequence of the last 200 years.
So was it just London? Do the French try to jump into this, or any of the other European cities?
Well, Paris does the same, and the issue is, do we regard this as two independent changes, or is it all basically lumped under one European transformation?
Because they're relatively close in terms of communication.
Very close, and socially very close, even though they were fighting each other.
So I'm guessing at that time, using the technology in the early 1800s, could you travel from London to Paris would it take you a 24-hour day? Or
Oh, no, it would take you more than that.
a couple of days?
Yeah.
That's still relatively quick.
Oh, it's relatively quick. Continentally, if you're going by carriage, or if you're going by carriage across the UK, by the time you get into the late 1700s and the early 1800s, you have very competent carriages.
So that was the last big jump, you're saying, the London/Paris thing?
That's the most recent one. And that is so powerful that almost as soon as it comes into being, all those capacities to make a huge city are exported to America.
Oh, so America copied that.
And Japan, almost instantly.
Japan copied it?
Yes, very rapidly. By the late 19th century, they are starting to seriously develop Edo, which is the Japanese capital. People tend not to know that Edo, the Japanese capital, was already 90 square K in the early 19th century. It was bigger than London originally.
Wow.
And the Japanese transformed their whole social, political, and economic system at incredible speed.
So I'm getting this overview now that you as professional archaeologists have seen of the settlement size increasing for the knowledge being transferred. But of course, they've got to manipulate their environment. They've got to have materials, all that sort of stuff.
Each one of these changes is a massive jump. It's what I call a punctuated, accelerated transition. And each one of them requires an enormous increase in the energy supply and an enormous increase in the information management capacity.
With energy, we've jumped from the labour of a human and an animal to the energy in fossil fuels.
That's right.
And the energy in fossil fuels is enormous. Like in a barrel of oil, 159 litres, or 200 kilogram pile of coal, you've got the energy of a labourer for 10 years.
That's right.
That's a huge amount of energy, which is why we started using fossil fuels. And the easy way to get that energy is simply to burn it, get the heat, and use that heat to somehow power an engine, either turn water into steam or internal combustion. Right, okay, so now I'm getting the big picture.
So you get these, essentially there are three huge transformations in the mode of operation. So we go from an agricultural mode of operation.
That's how many years ago?
That's 10 to 12,000. Then you get the urban transition, and the key to the urban transition is that it organises muscle labour, you can build pyramids and so on, and it organises eventually water management very effectively.
Oh, because you've got to have clean water in and you've got to get rid of your sewage.
And you've got to move water around the landscape. And then you get to the transition in the 19th century where we move to utilising fossil fuels. And initially we're using oil from the cetaceans. We're basically culling whales to get the lubricant to make our machines work, because we didn't initially use mineral oil initially. We only began to use that later on.
So then why do you say that we won't have Star Wars, no galactic empires, no foundation or empire, which breaks my heart as a big fan of science fiction, but I'm bound to your expertise. Why is that?
Because each time you get one of these big settlement size jumps, you get this transformation in the way the society is organised and the way it manages what it does. We have behaved as if the Industrial Revolution having happened, no more change is going to occur.
No more fundamental change, just more of the same.
That we've just got
faster,
there,
yeah, okay.
and that we would go on eternally in a metal-based machine technology using various familiar sources of energy, which we've got to, like, and fusion would come in using sunlight and so on. Catch is this, that as you can see from what I've described of 10 to 12,000, 5,000, and then the 19th century, the rate of change is accelerating.
Yes.
And if you follow that acceleration, the next settlement-sized transformation is in a few hundred years.
Right.
And it's beyond 10,000 square K. And this is where my low-density stuff comes in. Low-density settlements don't conform to this pattern at all. They do all sorts of different things. It's only the compact cities that do these huge jumps. So the next jump would be beyond 10,000 square K in a compact form. And there are no cities in a compact form that have got to that size at this point.
And in the future?
There will be, and it will be within 200 to 300 years. Because what is serious about that description of clocks and printing occurring several hundred years before the industrial transformation is that right now our society, by an equivalent, is churning up enormous numbers of new ways of doing things. And
yes.
Those are the tools. And for instance, digital information management is a primitive version of it. They're antecedents for what will be used for the next transition.
And you're saying there won't be metal-based technology?
When that next transition occurs, the rate of expansion that will be possible will go up 1,000 times again, which would be 5 million square K per century for the size of a settlement.
So that means 1,000 by 1,000 kilometres.
2/3 of Australia in a century.
Wow.
I don't think that will happen. I don't think that's what the next transition will do. I think it will do something quite different. But what it means is that the magnitude of that change in 200 to 300 years' time would be greater than the Industrial Revolution.
I'm finding it really hard to conceive what it might be.
It's very hard because, to give you a really extreme instance, if mechanical technology, which is what we've used up to now in this last few hundred years, becomes obsolete, it's very difficult to envisage what it would be replaced by. But to give you an instance, just a tiny instance of how serious it would be, mechanical AI, which is what we're working on at the moment, mechanical artificial intelligence, is the equivalent of a cathedral clock.
Ah, so you're saying that will be some tiny cog in the future mechanism
It's a primitive antecedent
to what will come.
Of what will come. And the implication is that what will come is something we're already discussing now, which is artificial organic AI. And once you get into that notion of organic artificial intelligence, we would then be moving into a world where the artificial intelligence was operating on the same rates and speeds and habituations as we do. We could get into a situation where an organic artificial intelligence would like us for the same reason that a dog likes us. The artificial intelligence likes to be stroked or something, or it likes to chat. That's the magnitude of what we would be looking at.
I'm trying to conceive this.
It's very hard.
It is hard. Like on one hand, Alastair Reynolds, Reynolds, in one of his science fiction stories, touches upon an organic AI as an important cog in the future society.
Yep.
I love his science fiction work, but I'm trying to think that the difference between 1903 and 1969. In 1903, on the 17th of December, I think it was, you had the first controlled artificial flight, and in less than a human lifetime, we got to the moon and back.
That's
so
right.
from 1903 to 1969. But secondly, the flight that the Wright brothers did, the width of the aeroplane would have fitted inside the fuselage of a 747, and the length of the flight would have fitted inside it.
Yes.
So part of me is thinking that you have now a new career as an advisor for a good science fiction movie, because so many of the science fiction movies, as opposed to the stories, are based on the wealthy control everything, everybody else is screwed and it rains a lot, and it's a dystopian society. But you're opening up more imaginative ways like the science fiction writers do. And so you're saying that we won't have the starships, but we'll have something different.
Quite different. If you think of the example you just used about the planes,
yes,
the difference in the future would be the equivalent, 1,000 times greater than that transformation. So the implication would be that what we really need in this discussion about the future is that group of science fiction writers who are associated with nature.
Wow.
And bring them together.
Biology is complex.
To ask really seriously, how would you envisage these kinds of futures? The saving grace for science fiction is that if you want metal machine-based technology, you can rampage through the solar system. That we will do. We will rampage through the solar system within the next 300 years using machine-based metal technologies. What we won't do is have interstellar phenomena. There are no interstellar civilizations. That's much too primitive.
Primitive, are they?
Much too primitive.
Oh my God, this is mind-blowing.
We're dealing with orders of magnitude of energy capacity and information transmission. I don't fully understand the information transmission concepts yet, but I'm going to learn, and I've learned some from you. The big issue that we face is that if these accelerations of change keep going, the future of an intelligent life form that keeps on doing that is very fast and very short.
Hang on, that last thing scares me, very short.
Yes, it's doing something that we don't understand, and it will ultimately be transforming its behaviour in some way we don't understand.
Wow, I'm kind of thinking of the concept of a bacterium living on my skin, not really being aware of me, and in the same way that we humans, thinking we're intelligent, might not be aware of another civilization.
They're not a civilization.
Well, not a civilization.
They're behaving. They're doing something.
Well, the thing is that we've got these big problems in physics, and one of them relates to this. So we've got the dark matter we don't understand, dark energy we don't understand.
Yeah.
We've got black holes we don't understand, and also the missing dimensions. So when the Big Bang started off, there were probably 11 or 12 dimensions, almost certainly.
Right.
And I'm kind of thinking that they, whatever they are, could be living or existing or whatever it is they do in these other dimensions, which are as difficult for us to understand as a bacterium living on my skin is having difficulty in understanding me. Netflix and Hollywood, please go and look for Professor Roland Fletcher. So you're to get some. I think they need to sit down with you for a couple of days and then pick your brain and try to work out some really good science fiction movies. Your official title is
Professor of Theoretical and World Archaeology.
Okay, so now as we come to the end, how can people contact you and follow you in your fine work and in fact become a PhD student or something like that? How can they contact you?
Well, I'm in the University of Sydney, which is why we're able to talk to each other. And we have very standard email addresses, which are our names, roland.fletcher@sydney.edu.au. That's the easiest way and the most reliable way to find
So forget social media.
That's the easiest way to find it.
Okay. Look, thank you ever so much for blowing my mind, and I'm trying to envisage these new civilizations. This will be very interesting as I try to drop asleep at night.
Well, one of the things we can envisage is that we would be able to see this behaviour. We would be able to see it because the energy capacities would be so huge and the information transmission capacities would be so huge. But radio's not in it. Radio is much too rudimentary. Whatever this new communication is, it's, as I crudely described to you earlier, it's bigger bandwidth. I don't know how it works. but we can already transmit information at the speed of light. It's now the quantity that we can transmit that's going to become crucial. And that's what we need to start looking for.
Thank you so much, Professor Roland Fletcher. I look forward to your new career as an advisor on science fiction movies as well.
I await learning something from science fiction writers.
Thank you.
They're the people with the game.
Shirtloads of Science is washed, spun and aired by the University of Sydney.